Probability test review. Question 1. A coin is tossed. What is the theoretical probability of tossing it heads and tossing it tails? Think about it. You have two sides to a coin. One side is heads and one side is tails, making a total of two sides. Your probability of flipping a heads would be 1 out of 2 because you have one side that is a heads out of 2 total sides. This would also apply for tails. You have one side that's a tails out of 2 total sides. So theoretically, you should get 1/2 for heads, 1/2 for tails. Question 2. The coin is tossed 20 times with the results to the right. Using the results, what is the experimental probability of tossing a heads and tossing a tails? We know that they tossed a total of 20 times. What we need to do is count how many times they flipped a heads. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So after they tossed 20 times, their experimental probability is that they flipped 11 heads out of 20 total tosses, which would mean their experimental probability for tails would be 1, 2, 3, 4, 5, 6, 7, 8, 9 times they got tails out of a total of 20 tosses. For questions 3 through 5, determine if the following scenarios are independent or dependent. Remember, independent is when your denominator does not change. And dependent is when your denominator changes. So for instance, flipping a coin 3 times. If I flip a coin, can I ever take away a side of a coin? No. My options are always going to be one side heads and one side tails. Therefore, flipping a coin 3 times would represent an independent event. Question 4. Selecting a marble from a bag, not replacing it, and then selecting another marble from the bag. For instance, if I started with 10 marbles and I took one out and I didn't put it back in because I'm not replacing it, that means I now have 9 marbles in the bag. Therefore, my denominator would change, and this would represent a dependent event. Spinning a wheel and rolling a dice. If I have a wheel made and I spin it 10 times, each time I'm always going to have the same amount of options. I can never take anything away from a wheel. Same for rolling a dice. I will always have the same numbers on that dice. I can never just take away a number, take away a side of the dice. Therefore, this would represent an independent event. Question 6. Preston places 4 white marbles, 6 blue marbles, and 8 yellow marbles in a bag. If he picks a marble without looking, what is the probability that the marble will be blue? First thing I need to do is calculate the total marbles I have in the bag. The total marbles that I have equals 18. Now I want to know the probability of that marble being blue. I look at how many I have now that are blue, and I have 6. So the probability that I choose a blue marble at random would be 6 out of 18. Make sure you simplify each option. I can divide both the top and the bottom by 6, and my reduced fraction becomes 1/3. Now the second part to that. What is the probability that the marble will not be blue? So what I'm going to think about is look at all of my marbles and count how many of those marbles are not blue. If I have a total of 18 and I know that 6 are blue, then I just count all the ones that aren't blue, which would be the 4 white marbles and the 8 yellow, giving me a total of 12 that are not blue out of a total of 18. Again, make sure you simplify. We can divide both the bottom and the top by 6. And so our reduced fraction becomes 2/3. Question 7. A customer at Lee's Lunches can choose a protein from chicken, beef, or shrimp. The customer can choose from white or brown rice. Create a diagram to show all of the combinations if you can choose one protein option and one choice of rice. How many choices can you choose from? So I can choose from 2 things. I can get one protein. And I can get one choice of rice. My options for protein are chicken, beef, or shrimp. And with those protein options, I can choose between white or brown rice. So if I choose chicken, I can choose chicken with white rice, or I can choose chicken with brown rice. I could choose beef with white rice, or I could choose beef with brown rice. I could choose shrimp with white rice, or shrimp with brown rice. I have made my tree diagram. The next thing I want to do is count how many options I could have. And with counting with tree diagrams, you're always just going to count the last of the branches. Because if I counted all of it, that would just mean all of the options I have. But I really want to know my one protein plus my one rice. So I could get chicken with white rice, that's one option. Chicken with brown rice, that's second. Beef with white, third. Beef with brown, fourth. Shrimp with white, fifth. And shrimp with brown, my sixth. So I can have a total of 6 options. Question 8. Benita observed that 68 out of 55 patrons at the public library used the computer. The librarian told Benita that 660 patrons enter the library throughout the day. Based on Benita's observations, how many patrons during the day would expected to use the computer? So we need to make a box. What we know versus what we want to know. The 2 things we're comparing the people who use computers versus the total number of patrons. Now we separate it between what we know and what we want to know. We know that 28 patrons use a computer out of 55. What we want to know is How many patrons use a computer out of 660 total patrons? Set up a box. Create a cross product and solve for x. $28 times 660 equals 8,480. We're going to equal that to 55x. Next step is to divide by 55 from both sides. 55 divided by 55 cancels out. And 18,480 divided by 55 equals 336. So out of 660 patrons, 336 of those would use the computer. Question 9. A 6-sided number cube with each of the numbers 1 through 6 on one face of the cube is rolled. What is the probability of rolling a 1, then rolling a 6? So we're rolling 2 times. That means I want to create an upside down T-chart. My first roll, I want to know the probability of rolling a 1. Then I want to know the probability of rolling a 5. We can't change the number of sides on a cube, so our denominator will stay the same on both. My probability of rolling a 1 on a number cube would be 1 out of 6 because there's only one on a number cube. My second spin, I still have 6 sides, and my probability of rolling a 5 would be 1 out of 6 because there's only 1 5 out of 6 sides of the number cube. When you have multiple probabilities, means you're going to multiply. So the next step is to multiply. 1/6 times 1/6. When multiplying fractions, you multiply across. 1 times 1 is 1, and 6 times 6 is 36. You cannot simplify, so your probability is 1 out of 36. Question 10. A gumball machine has 14 green gumballs, 10 red gumballs, and 6 blue gumballs. What is the probability that the next 2 gumballs selected will be red? Hint: if I'm getting a gumball out of the machine, can I return it back to the gumball machine after I get the first one? The answer is no, because once you take a gumball out, you can't just stick it back in the machine. Therefore, the amount of gumballs in the machine will decrease by 1 each time. Since we have multiple probabilities, we need to set up our upside down T-chart. We want to know the next 2 gumballs selected will be red. So the first time I get a gumball, I want to know the probability of it being red. And it says the next 2. That means I want to know if my second gumball will be red. You can set up a pitcher with 14 green, 10 red, and 6 blue. Which makes a total of 30 gumballs in the machine. Okay, so what is my probability of choosing a red? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 30. So I have a probability of the first time I get a gumball to be 10 out of 30. But since I'm taking a gumball out of the machine, that means I'm going to take away a red marble. And now I have a total of 29 gumballs. Now, what's my probability of getting a red gumball this time? Since I took a red one out the first time, I now have 9 red gumballs out of 29. You can go ahead and simplify 10 over 30 to 1 over 3 to make it easier for you to multiply. You have 1/3 times 9 over 29. Multiply across and you have 9 over 87. You can divide both sides, the numerator and the denominator by 3. And you should get 3 over 29. Question 11. Joanne has 10 green socks, 10 red socks, and 20 white socks in her sock drawer. What is the probability that Joanne pulls 2 red socks without looking or replacing? Since I have multiple probabilities, I'm going to make my upside down T-chart. My first time I pull one out of the drawer, I'm looking for it to be red. And it says pulls 2 red socks. That means I'm going to find my probability, again, of a red sock. I need to find the total amount. 10 plus 10 plus 20 is 40. The first time I pick, I have a total of 10 out of 40 red socks. So my probability is 10 over 40. But then it says without replacing it. That means I now have 9 red socks in my drawer out of 39. So my second choice, my probability of getting a red now would be 9 out of 39. I can simplify 10 over 40 to equal 1/4 before I go ahead and multiply. And I can also simplify 9 over 39 by dividing by 3, which gives me 3 over 13. Now I need to multiply those two. 1/4 times 3 over 13, and I get 3 over 52. 3 over 52 does not simplify. So my probability of choosing 2 red socks without replacing would be 3 out of 52. Question 12. What is the a student spins the spinner and throws a 6-sided number cube. What is the probability that the spinner and the number cube will land on even numbers? So I have 2 probabilities. Set up your T-chart. I'm looking for the probability of an even and a probability of an even again. I have a total of 6 sides on a number cube with 1, 2, 3, 4, 5, and 6. We want to know the probability of an even number. My even numbers are 2 4, and 6. So the probability of choosing an even number on a dice would be 3 out of 6. Now I'm going to look at my spinner. I have a total of 8 equal slices. And out of that, I have 1, 2, 3, 4, 5 even numbers. I can simplify 3/6 to 1/2, and then I can multiply my two probabilities. 1 times 5 is 5, and 2 times 8 is 16. These cannot be simplified, so 5/16 is your answer choice. Question 13. A bag contains 3 red marbles, 5 green marbles, and 2 blue marbles. 2 consecutive draws are made from the bag without replacement. Find the probability of each event. So I have multiple events. I make my T-chart. In my first event, in part A, I want to find the probability of a red, then the probability of a blue. I know my total, 3 plus 5 is 8, plus 2 is 10. First off, if my first draw, my probability of a red would be 3 out of 10. But it's without replacement. So now that makes me have only 9 because I take away a red marble. Now what's my probability of a blue? I still have 2 blue marbles in my bag, but now I have 9 total. So my probability of a blue would be 2 out of 9. Multiply across, you get 6 over 90. You can divide both by 3, and you get 2 over 30, which can be simplified by 2, and you get 1 over 15. A blue and a blue. My probability of a blue is 2 out of 10 on my first draw. But I don't replace it. So now I only have 1 blue marble, and my new total is 9. Multiply across, and you get 2 over 90. Divide by 2, and you get 1 over 45. Probability of both draws were neither red or green, meaning they were only blue. So it's basically what I'm asking here, it's just in different words. So the probability of it not being red or green would be 2 out of 10 because I only have blue options left. Take 1 out, and then I have 1 over 9. 2 over 90, which simplifies to 1 over 45. Okay, so now this one. I want to know the probability of a red and then a probability of not being red. My probability of red is 3 out of 10. I take a red one away, I now have a total of 9. My probability of it not being red would be 5 greens plus 2 blues, since they're not red, which gives me 7. And since I took a red one out before, I now only have 9 total marbles. Multiply across, and you get 21 over 90. These can be simplified by 3, and you get 7 over 30. And that's as simplified as it gets. Question 14. A bag contains 3 red marbles, 5 green, and 2 blue. 2 consecutive draws are made from the bag with replacement, meaning every time I choose a marble, I put it back in. So my total marble stays the same. Find the probabilities for each event. I have a total of 10 marbles. Now I need to find my probabilities. I want to know my probability of choosing a red marble first. Well, I have 3 reds out of a 10 total. So my probability is 3 out of 10. Then I replace that marble, meaning I put it back. So I still have 10 marbles in the bag. Now I want to know the probability of choosing a blue marble. Well, I have 2 blues out of 10 marbles because I returned it. Multiply across. 6 over 100. And I can divide by 2 and get 3 over 50. This cannot be simplified, so your probability is 3 out of 50. My probability of choosing a blue and a blue again. Well, I have 2 out of 10 blue. I replace the marble, and I still have 2 out of 10. So I get 4 over 100, which simplifies to 1 out of 25. Probability both draws were neither red or green. My only options of neither red or green is blue, in which we found that in part B. We know the other options other than red or green is blue, so I have 2 blues out of 10 and 2 out of 10, which gives me 4 out of 100, which gives me 1 over 25. D. Find the probability of a red marble and then the probability of not red. My probability of a red marble is 3 out of 10. I put that marble back in the bag, so I still have 10 total. Now, what's my probability of choosing a not red marble? Well, I have green and I have blue, making 5 plus 2, 7 not red marbles out of a total of 10. Multiply across and I get 21 over 100. 21 over 100 cannot be simplified, so that is my probability. Question 15. Tim rolled a number cube 30 times with the following results. Based on the results, predict the number of times she can expect to roll a number 1 in 120 rolls. What I want to do is look at what I know. I know that Tim rolled 2 number 1s out of 30 times. I want to predict how many times Tim will roll a number 1 if he rolled 120 times. So I set these up as fraction ratios, and I just created a box around it. Now I just solve for x. I can either create a cross product or use my multiplication. I know that 30 times 4 is 120. So what I want to do to the bottom, I do to the top. 2 times 4 equals 8. So I could predict that Tim will roll a 1 8 times out of 120 rolls just based on his data. Question 16. Raymond caught the football 28 out of 35 times at practice. Predict the number of times he will catch the football during a game if it's thrown to him 20 times. So we know he can catch 28 out of 35 tosses. Okay? We want to know how many he can catch out of 20 tosses. Solve for x. Create a cross product. 28 times 20 equals 35x. 28 times 20 is 560. We're going to equal that to 30x. Divide by 30. And you get 8.67, which would round to about 19. Excuse me, I gotta divide that by 35. My mistake, guys. I knew that didn't sound right. My apologies. 560 divided by 35, which equals 16. So they will make 16. They'll catch 16 out of 20. My apologies. Went too fast. Question 17. Joanna will roll a fair number cube 90 times. How many times can she expect to roll a number greater than or equal to 5? So let's think theoretically. Theoretically, if she rolled the dice one time, and her probability theoretically for rolling once would be greater than or equal to 5, so her only options are 5 and 6. So 2 out of 6 total sides. What we want to know is if she rolled 90 times. We know that 6 times 15 equals 90. What we do to the bottom, we do to the top. So we should expect her to roll a number greater than or equal to 5 30 times. Question 18. The defective rate for phone chargers is 1.5%. If the store ordered 250 chargers on Monday, how many of the ordered phone chargers will be defective based on this information? So what it's asking basically is, what is 1.5% of 250? The reason it's basically asking that question is because we want to know, out of those 250, that 1.5% is expected to be defective. So we need to find how much 1.5 is. 1.5% is of 250. If you remember your box, you're going to set it up with is over of and percent over 100. So we're looking for what is 1.5% of 250. Percentage is always out of 100. And now solve for x. 250 times 1.5 equals 100x. We have 375 equals 100x. Divide by 100, divide by 100. And so x equals 3.75. Or we could round that out to about 4 chargers. Question 19. On average, a restaurant experiences 4% cancellation rate on dinner reservations. If the restaurant has 400 dinner reservations, how many reservations can we expect to serve? So if 4% cancel, how many do they expect to have? Well, we want to find the percentage of that. 100% minus 4%. So they have 96% of people who don't cancel, meaning that they serve them. So we want to know how much 96% is of 400. Create a cross product, create a box. Is over of percent over 100. We want to look for the 96% that they are going to serve out of the 400. Create a cross product. 400 times 96 equals 100x. 400 times 96 is 38,400. We're going to equal that to 100x. Divide by 100. You can cancel out your matching zeros, and you're left with 384 divided by 1, which equals 384. They should expect to serve 384 guests. And lastly, question 20. Matthew will spin the spinner 80 times. Predict the number of times he will expect to land on a number greater than 3 but less than 7. So if he spun once, the probability of spinning greater than 3, so a 4, 5, 6, 7, or 8, but then less than 7. So his only options are 4, 5, and 6. So his probability if he spun once would be 3 out of 8. But we're looking for how much out of 80. We know that 8 times 10 is 80. What you do to the bottom, do to the top. 3 times 10 is 30. So they should expect to spin a number greater than 3 or less than 7 about 30 times.